Hi everyone, welcome to our channel. I hope you are enjoying different videos on our channel. So as part of today's class, I'm going to help you make your first machine learning model. So when I made my first machine learning model, I was very excited. So I hope you have the similar kind of excitement and you are eager to know that how to create a machine learning model. So the purpose of this class is to introduce you to the core ML concept, basically the ML terminology which we are going to follow in our future classes. It will make things easier for you to understand in our future classes. So that's the whole purpose of this class. We are not going to go into feature engineering, exploratory data analysis, and a lot of depth of building a model. It is going to be a hello world kind of a model for you. So let us define our problem statement. So we are going to use iris dataset for this class. So if you have worked on machine learning earlier, you might have definitely heard about this iris dataset. So uh, iris dataset is about uh, you know 150 measurements, 150 flowers whose measurements were recorded. So uh, all those 150 flowers were of three species. They were either Setosa, either versicolor, or either Virginia. They were only one out of these three species, and as part of the data collection, they had collected petal length, petal width, and speckle width. We'll see in few minutes that what is petal length, and all that. So all the data about the flowers was calculated uh, and stored in this data set. Now what do we want to achieve? We want to achieve, as part of this exercise, that we want to make a model. uh, to that model we will give input as different measurements of a flower, and it should tell us, it should predict that what is the species that flower belongs to. So I hope this problem statement is clear. I'm going to repeat it in a simple words again. We are going to give different measurements to our machine learning model. That is going to be our input. And what we expect from our machine learning model is to tell us that those measurements belong to which flower species. Okay, let us understand our data. Okay, this is a petal. So we are going to have sepal length, sepal width, petal length, and petal width. These are the four measurements we are going to have about our flower. So now this is a petal. Petal is a very thin and long kind of you can say as a leaf. It's not exactly a leaf. It's a thin and long part of the flower. So if that petal is broader, a bit broader, and similarly long, it is called sepal, and it has some marks also. Sepal has some marks also at the lower side of it. So we have data which is recording length and width of petal and length and width of sepal. And for every these four readings, we have the class label, whether it is Setosa or whether it is versicolor or whether it is Virginica. So this is the data that we have. Let us jump on to our code. Okay, so I have already created a Jupyter notebook. So in my first class, I had mentioned that we are going to use Azure notebooks because on my machine, I don't have much of RAM and capacity. Azure provides it for free, so I'm very happy to use it. I'm very thankful for them, of them also, to let us use it for our class. Okay, so I have already written some of the code here, and we can I'll explain you as we go as part of this class. So pandas, NumPy are two libraries that we are going to use for our classes going forward. Pandas is a library which lets you can read a file and you can visualize it as a spreadsheet, as a table, and then you can run SQL queries on that table, and you can run many uh, selecting a column, filtering some rows, those kind of operations on your data set. So pandas gives you capability to do all those kind of operations. NumPy is numerical Python. It is a library which is internally used by pandas, and you know uh, it also lets you process data. So we are not going to use NumPy a lot. We are going to use NumPy through pandas. So pandas makes our life easy. So you can think of it as that. Scikit-learn is a library, is a machine learning library, which we are going to use to train our models and do any kind of accuracy checking or any kind of uh, you know uh, deep learning kind of exercise, any kind of that exercise we are going to ML kind of exercise we are going to do through uh, scikit-learn. Matplotlib is a library which is used to uh, plot your data. If you want to visualize your data in form of scatter plot, or in form of pie chart or histogram or something, we'll be using Matplotlib for that. So let us import these libraries. Cool, our libraries are imported. So now, okay, so matplotlib inline. So this is a magic function which is used to tell the system that if any image is drawn using matplotlib, show it as part of this notebook. This environment is called notebook. I'm just saying it for people who are not aware that what is a notebook. So let me run it. Cool, this has a run. Now, scikit-learn comes with a lot of data sets which you can use to learn. It comes with the breast cancer data set, it comes with housing price data set, it comes with the iris data set, it comes with digit recognition data set. So, lot of data set it comes with. We are going to use iris data sets. So, let us load the data set. Okay, so now we want to see, we have loaded the data set, but now we want to see what are the things that we are getting as part of this data set. Okay, so we are getting some information, some description, column, which is going to tell us that about the data set, that what are the columns, and what is the type of columns and all that. We'll see this information in few minutes. Uh, there is going to be a data column which is going to have the data that was recorded, measurements that we were talking about, right? So this is the data that we are interested in. Uh, Target is a column which gives us output class. It is going to tell us that it is Setosa or vernicolor or virginica, which is a species. Target names and feature name. Let us see, what is there in these things. So here I am just printing first 500 lines. So for this iris dataset, I am accessing this description column, and I am getting first 500 rows. So we can read it. So it is telling us that it's plants database, and number of examples that we have is number of rows that we have in this dataset are 150, and there are three classes: sepal, iris setosa, iris versicolor, and iris virginica. And for each class we have 50 samples. And there are four attributes which are recorded: sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter. You can see some more information if you want, just by changing it here. So this is giving you summary statics, that what is minimum sepal length and what is maximum sepal length, what is mean, what is standard deviation, what is class correlation. You don't need to worry about it as of now, so we will calculate all these things by ourselves. Okay, let us see what are the features that we have. So these are the 4 features we are going to have, and let us see first 5 lines of our data. Cool. So this is how we are going to get our data. Let us see our output target variable. Okay, our target variable here, it is showing as 0, 1 and 2. These are the distinct values. So just to clarify on this, so our target variable are Setosa, versicolor and Virginica. So Setosa in this array is replaced by 0, versicolor in this array is replaced by 1, and Virginica is uh, replaced by 2. So this is a way of encoding that you will see in in machine learning. So rather than talking in textual terms, in machine learning we like to talk in terms of numbers. So here each class, Setosa, versicolor and Virginica, is assigned a number. Setosa is assigned a number 0, versicolor is assigned a number 1, and Virginica is assigned number 2. So why we like to talk in terms of numbers in machine learning, I'll explain in detail in our next classes. So I don't want to confuse you with all those encoding and all that stuff here. So you can just think of it as that in machine learning, we like to think in terms of numbers rather than in terms of textual data. Okay, so let us see the shape of our data. Okay, shape of data is like we have 150 rows and 4 columns. So you can think of it as a matrix. So every row represents one record for one flower, and there are 4 columns. Like we are calculating 4 feature. We have 4 features with us: sepal length, sepal width, petal length, petal width. Okay, target. So in target we have information about species of 150 flowers that is expected. Okay, so whenever we train, okay, so now we will be training our model, and whenever we train a model, uh, we don't want to train our model on whole of data set. Okay, what is the reason for that? So reason for that is that we want some data to test our model also, model accuracy. So what we do is that if we have 100 records, we will give 75 or 80%, whatever is your choice. Um, we'll give 75 or 80% records to train the model. We'll use 75-80% records to train the model. We'll create a model, and then we will test the accuracy of that model on rest of 20-25% data. How this helps? This helps to confirm that our model has not remembered all the values. So when we train a model, uh, what is a model? So first of all, we should understand what is a model. Model is a mathematical formula. You can think of it as a mathematical formula. When we train a model, we want that model to be generic. So that it can be applied on multiple situations. We don't want our mathematical formula to remember the data as is, because if it will see any unseen data, it will not be able to do any good prediction. So we want our model to come up with a good formula which can be applied in multiple situations rather than only in situations which it has seen. So that's the purpose of splitting our data set, input data set, into 2 parts. First part is going to be training, and second part is going to be testing. So scikit-learn comes with a function which can help you split your data set into 2 parts. So you just need to import that module. So that module name is train test split. So this is a function, we are using it here. To it we pass the data and we pass the output. It will give us 4 sets. Let us run it and then I'll explain it. It has given us 4 sets. Okay, in X train. So our input we normally donate as X, and our output we normally denote as y. Now, uh, when we are training our model, we will give it training level input and training level output. So training level input is xtrain and training output is ytrain. So we are using 112 variables, sorry, 112 rows of our iris dataset to train our model, and 38 rows of our iris dataset to test the accuracy of our model. That's how we are going to use it. So our output for training data has also 112 rows, and our output for test data also has 38 rows. That's the expected thing. I hope this is clear. If it is not clear, please rewind the video and see. I, it is a simple thing, and I don't want you guys to be confused with this thing. If you still have any question, please post it in comment section. Okay, so now it is a classification problem. So since we are saying that our output is going to be only one of the three class variables, it is either going to be setosa or going to be vernicolor or going to be virginica. So logistic regression is one of the classification algorithms. I will explain logistic regression in a separate session in detail, but just wanted to tell you that it is for classification. So uh, scikit-learn already has a uh, implementation of this algorithm. We'll use the implementation. We have created an instance of this algorithm. Now we'll train our model. So fit is a function which is used to train our model. So we are giving our training data. So we have given the data and the relevant output. Cool. So our model is trained. Awesome. Now X test is our test data. We can test the we can do the prediction on our text data. Okay, predictions are done. So now we want to see, first of all, let us run it. We want to see that how good are our predictions as our uh, in our test data. How good is our model? Okay, our model is able to accurately answer everything that is in test data. And in training data, it is giving us 96% accuracy. Okay, so before doing this, I would like to show one more thing. So let us resplit our data. Again, it has given us 112 samples, and let us start our logistic regression object again, and let us train this model again. Let us do the predictions also again. Now let us see the accuracy. Okay, now you might have seen that accuracy in the test has decreased from 1 to 0.92. So the reason is that when we do train split, scikit-learn is randomly odds out of 150. So in our first instance, by luck or by some situation, uh, it had selected all the records which were uh, which were same as white test, which coincidentally gave the exactly same result. So once when I reran it, it is giving me different result. So it is giving me 92% accuracy. You can see there are many ways to uh, calculate the accuracy of a model. So in scikit-learn metrics module, there are a lot of functions which are used to train a model. So to check the accuracy of a model, so mean squared error is one in case of classification algorithms. You can see that mean square error here is pretty low, 0.07 is it is. So This is very simple example of how to build a model. I hope it is very useful. So you can actually create any other model also. Sklearn. Let us create a tree-based model. We'll we'll create a decision tree from it. Let us give it some input. Awesome, it has trained a tree. Now let us try to predict it. Awesome, it has done the predictions. Now let us calculate the accuracy of this. Uh, awesome. So decision tree was clearly able to distinguish between, there is no error. A decision tree was clearly able to make distinction between iris, different classes of iris dataset. So we'll go into details of it, that why 100% accuracy is not a good scenario. We'll go into details of that. So I hope you enjoyed this class. You know, if you have any question, please post it in comment section. I'll be very happy to answer that. Thank you.